So Joe measures the side of a square, correct to 1 decimal place. We don't know the units yet. He calculates the upper bound for the area of the square as 37.8225 centimeters squared. So we're going to say he's measuring centimeters. Work out Joe's measurement for the side of the square. It looks a little complicated. All right, let's draw a square. And the side, well, it's of course all the sides are the same length. And we're told the side is correct to 1 decimal place. The area is the space inside of the square, which of course is the side squared. And we're told the upper bound for the area. So we don't know what he actually measured it at, but given his accuracy, we're told, well, this is the upper boundary for it. So doesn't look like we have a lot to work with, does it? But we're going to break this down and try and work out what do we do with these boundaries to work out upper boundaries and of a calculation. So let's just start with the side that he measured and say, if you had a side, there would be a lower boundary for the side, let's call it SL, and there would be an upper boundary for the side, let's call it SU. And we know from having done questions simple versions of this, that there are those two boundaries. We also know for the area that there'd be a lower boundary for the area, we'll call it AL, a subscript L, and there would be an upper boundary for the area. Let's just call it a subscript U for the moment. And then we're going to ask the question, because they gave us the upper boundary for the area, how do you find the upper boundary for the area in this case? Well, the area is side times side, so we're multiplying two numbers together. And how do you find the upper boundary when you multiply two numbers? Well, you take the larger of either of those numbers and multiply them together. In this case, it's the same number because it's the side times the side and they're the same length. And so we're actually going to take the upper boundary for the area is equal to the upper boundary for the side times the upper boundary for the side. And of course, that equals, we can rearrange that, so that the upper boundary for the side is the square root of the upper boundary for the area. Ooh. All right, in this case, we're now trying to find out, well, what's the upper boundary for the side now? We're doing the square root of the area, and how do I find the largest boundary? Well, I just need the largest boundary for the area, which they gave us, so we just do the square root of 37.8225, punch into your calculator, and we'll get 6.15. All right, and now that tells me the upper boundary. Okay, given that it was, the original question told us it was correct to 1 decimal place, so this is really handy for us because 6.15, we know that, well, if that's going to be an upper boundary and you're rounding to 1 decimal place, anything below 6.15 is going to round to 6.1 if we go to 1 decimal place, which then means the lower boundary is going to be 6.05. So we have the two boundaries for the question. And that means that Joe measured the side to be right in the middle there, 6.1 centimeters.